the title of this talk is Encryption, Privacy and Encryption on the Mac. And to just give you some background as to what my personal background is, I started using Macs before I ended high school, and it opened up a world of technology to me. I had a PC at home and didn't really get a lot out of it, and then I went to high school and was exposed to Macs there, and became basically the student Mac administrator of my high school. And I spent the summer between my junior and senior year retrofitting all the software package on all of the computers at the school. And at the time, these were Mac Pluses and Mac SEs. They were ancient systems. Even at that time, they were like 10 years old and very neglected. And I installed all the latest software and made the most of what I could with what I had. It took me the entire summer to distribute that software package to all 20 or 30 machines. And then after high school, I worked for an internet service provider, and then sometime later, I ended up at Apple in Cupertino, California, and I worked as part of the worldwide sales support organization, and supporting their servers, developing DVDs, CDs and DVDs, and then left Apple to work at the Apple retail stores. That was a new project, seemed very exciting. I could move back to New England. Then left the retail stores, left Apple, met my wife, and then we ended up going back to California, and this time ended up in the training group at Apple. And so I became basically the lead tech support person that was not a developer for training.apple.com. And it was during this time that I started learning more about libertarianism. More privacy issues kept coming up because of the Bush administration and the way that they were expanding their scope. And so, not that I have anything to hide, but it seemed that they were pushing that Fourth Amendment envelope a little bit too much for my interests. And so I started learning more about encryption, more about privacy technologies. And so my personal setup is a little, it's really not necessary for the way that the type of information that I deal with, but should I ever be subpoenaed or somebody wants to confiscate my laptop, or if I were to just lose it, I wouldn't want somebody to have all my data. I have some sensitive information on there. And some of the times when people would be stopped, for example, the Motorhome Diaries group went to Canada and they confiscated their laptops. And I thought, not that they have anything to hide, but I wouldn't want any government agent to be just rifling through my documents and my information, because it's just none of their business. So there's a couple different aspects to the type of information or the type of encryption and privacy technologies that I'll be talking about. There's the data at rest when it's on your system, stored on the hard drive. There's the data in transit when it's going over the wire, over the network, over the internet. And then there are some things which aren't encryption-wise, but they enhance your privacy or make it a better internet experience, for example. So there's going to be a lot of URLs or different software things that I'll talk about. Because of the light, I can't really project, so we'll miss out on that. But unlike on a PC where you have a variety of different systems, you have BIOS from hundreds of different manufacturers, different versions of Windows, and because all Macs come from Apple, and even in the PowerPC days, and then they made the Intel transition, the systems are basically, is it an Intel or PowerPC system? And today, all the systems are Intel systems, and so that's pretty much what I'm going to be talking about. The way that an Intel Mac boots is instead of booting into a BIOS with a standard PC, it boots into something called EFI. And EFI is the next generation BIOS from Intel, and it was intended to be the next generation standard for Windows Vista, until they pulled it at the last minute and only went out with Windows 64-bit Vista.
Who pulled it? Apple or
Microsoft? Microsoft decided that, you know what, putting that much effort, engineering effort, into supporting EFI on 32-bit systems isn't worth it at this time, and they were already way behind schedule. So they're like, we're only going to do it for 64-bit systems.
EFI stand for?
It's extensible firmware interface. It's a method of booting similar to BIOS, but since BIOS came from like the early 80s, it was, we only have 640K of RAM, let's load enough of this operating system so then we can recognize, you know, all 2 gigs of RAM. And EFI was intended to be a modern replacement for that. There are EFI implementations not from Apple that allow you to network boot or load an operating system simply into EFI, into that EFI space, without having to even hit a disk, or, you know, you could load an operating system over USB or FireWire or Ethernet or whatever types of interfaces you have. Now on a Mac, you are guaranteed to have USB, because every Mac has USB since 1998. Most Macs have FireWire, and most Macs have Ethernet, and all Intel Macs will have airport or wireless Wi-Fi networking. The current Macs that are out there today can boot boot off USB, they can boot off FireWire, they can boot over the network. The latest ones can boot up, well, they all can boot off DVD. The latest ones can actually boot over Wi-Fi. You don't even need to be wired to anything. If you have a base station that's connected to a network that has a network boot server, you can actually boot over the Wi-Fi network. It allows you to associate with a Wi-Fi network, even a protected Wi-Fi network associated with it, look for network boot, net boot servers, and boot. And so the significance of EFI is that because it's such a robust method of loading an operating system, you can actually have a very small boot partition, let's say 200 megabytes, and PGP whole disk encryption can put enough information on there so that instead of booting into the standard macOS 10 kernel, it can boot into the PGP bootloader. That PGP bootloader will ask for your password, and at that point you have no keyboard map in place, and so it's the standard QWERTY layout. So if you're using a Norwegian layout, you're typing standard English characters into that, because you have just a it has only standard keyboard input at that point. Yeah.
I'm getting the impression, although you haven't stated it specifically, that the EFI is different from the BIOS, and that the EFI is not in ROM.
It is. You're right. It's not in ROM. It's when you partition an Intel Mac, when you create a volume, that's what they call them. Partition it into a single one volume on a Mac. It actually silently creates a 200 megabyte EFI partition for you. So if you decide to install macOS 10 onto that hard drive, it will put certain little bits into that EFI partition, so that when the system boots, it looks to that EFI partition, pulls enough of the information off of it in order to load the rest of, because you could have a 2 terabyte disk, and maybe, and I don't think this is an issue on a Mac, but it might be under PCs where it can't recognize anything beyond 128 gigs or 2 terabytes. If you have a 3 terabyte disk, which they're talking about, BIOS is having an issue where it can't even. I understand that there is a disk there. It's got 8 kilobyte sectors, and it's off the table. You need to have a small disk to boot from, and then it can recognize a 3 terabyte disk. So you can update the EFI partition when you install a new version of macOS 10. Yeah.
When you have an EFI partition, you bring that up, do you see the other PGP partition?
You can, well, in the standard macOS 10 EFI environment, there's not an EFI shell. Intel has written an EFI shell, so you can like poke around and do things. When you use PGP whole disk encryption, it simply asks you for a password, and until you type in the right password, it doesn't know how to unlock that other partition.
Okay, one of the criticisms of the PGP whole disk encryption has been that its presence was rather obvious. and that anybody, say a customs agent looking
Yep.
at your machine would see that.
Yep. Well, so my experience has been that unless you are a forensic agent working for the government and you have something to hide, and they are going to put all of their resources into finding out what you have to hide, the police and the general law enforcement is not going to have anyone nearly technical enough to even be able to identify
Sure,
that
they
you
use
have an
pre-canned
encrypted.
programs.
Yeah. So,
Yeah.
again, on a Mac, you have PGP whole disk encryption, which allows you to encrypt your boot partition. So you get to an EFI encrypted disk, and you look at that PGP encryption partition, and it will tell you. The first thing is say PGP WDE for whole disk encryption 01 if you were to just to do a data dump of the first like 10 bytes of the disk. And so it does identify itself as a whole disk encrypted disk.
Mm-hmm.
And really only if you are a target of some sort of government investigation, they would really need to put some serious resources and have some smart people looking at your data, trying to find out where your data is, how it's encrypted, and everything. And they would really need to have your passkey, your passcode, in order to be able to decrypt your whole disk encrypted disk.
Well, as long as you don't get into rubber hose cryptography or cryptanalysis.
So, so the reason why I like PGP whole disk encryption is because it allows you to encrypt your boot partition, and it encrypts it at the EFI level. Before the operating system is loaded, you can't get beyond that one step. Yeah.
Have you done anything with the open source Truecrypt?
Truecrypt is coming up next. So, so the way that I have my personal system set up, I have two disks, and one is a solid state disk. It's a fast Intel 64 gig disk. That's where my operating system lives, and all of my data is stored on a separate, fully encrypted 500 gig disk. So I have plenty of space to play with, and people can still boot my system. And until they log in with a certain user and then log in using my whole disk encryption password, they're not going to be able to do anything with that second disk that's in there. It's just not even going to mount, it's not going to show up, it's not going to do anything. So the other option for encryption on the Mac is Truecrypt. So PGP is pgp.com, Truecrypt is truecrypt.org, and Truecrypt will allow you to encrypt a disk or a partition in a way that gives you plausible deniability. It's like, if you look at it, there's no header information. It could look like just random data, and if somebody were to say, "Do you have encrypted data on there?" You could say, you know, if it wasn't your data, you could say, "No, as far as I know," and no one could prove you otherwise. Because there's nothing readily identifiable like that PGP header on the PGP disk. So the drawback on the Mac, at least, is that, as I understand it, Truecrypt does not support boot partitions on Mac OS X. I believe that Truecrypt does support boot on Windows, an encrypted boot partition on Windows, but as of last time I checked, it did not on a Mac.
I believe it does on Linux.
It very well may do it on Linux too, yeah.
I'm confused about what you said about plausible deniability. I would think that if they look at the disk, they couldn't just look at the disk and tell it was encrypted. Or they'd have to pull a connector off and look at the disk that way.
Even if they were to pull off the connector off the disk and mount it in a case and then connect it to something, there is no standardized header to say, oh, well, this is encrypted with Truecrypt. You can't even tell that there's an encrypted partition there without the passkey, the passcode. So
they could tell that there was random...
They could tell that that's in an unformatted disk as far as they could tell, or it once had data on it, and there's ones and zeros everywhere, but there's no standardized, like, pattern that they could see.
There's no fingerprint of Truecrypt?
No fingerprints.
You wouldn't see it in the file system.
And you wouldn't see it in the file system. It would look like an unformatted disk.
See, that's a criticism of PGP.
That it does have the header, and there is no plausible deniability.
Yeah,
of PGP.
that's been one of the criticisms.